Hello, everyone. Welcome to the DI 101 webinar series. This is, if you're not familiar with this series, I'll tell you that this is an incredible resource offered to our customers, partners, and associates. By partnering with our manufacturers and our industry experts, we will deliver informative presentations about industry trends, new technology, new products, and product applications. We're extremely excited to partner with Armacell for today's webinar. Today's topic, Armacell will discuss installation solutions for acoustics. Let me introduce our presenters. We have Jack Blundell. He is the specification manager for North America for Armacell. He has a bachelor's degree in mechanical engineering from Michigan Technological University and an MBA from the Bauer College of Business at the University of Houston. 11 years of experience in the installation industry, with various roles that have included responsibilities over business development, technical support, product management, and specifications. We're happy to have Jack and all of his experience and wisdom, and we are proud to have him present today, and we certainly thank him for his time. We will answer questions at the end of the webinar. To submit questions, please use the questions tab in your GoToWebinar control panel. You can submit your questions at any point during the webinar, and we will answer the questions at the end. Without further delay, I will turn this over to Jack with Armacell.
Thank you very much, Jared. I appreciate the kind introduction. And hello, everyone. On behalf of Armacell, we are very excited to be a part of this educational webinar series. DI really is providing a great platform for their partners to deliver informative presentations that adds value to our industry by generating awareness, regarding trends, products, and new technologies. So we really appreciate DI hosting this event, and also all of you online taking time out of your day to be with us. For heavy industrial facilities, a significant source of noise is piping radiated noise. And the impact of noise from industrial facilities has significant effects on health and safety. And reduction in noise levels is inherently beneficial for people and the environment. While it's common knowledge that various insulation materials are available to help with noise reduction, the ability for companies to deliver really true acoustic technical expertise by making recommendations, performing assessments, and providing practical solutions, that part is not as, easy or well understood. So today, we will discuss insulation solutions for noise control in industrial facilities. And as this presentation will show, if the answer to the question, do you have a noise problem, is yes, Armacell we can help. So as Jared mentioned, my name is Jack Blundell, and I am the specification manager responsible for all of North America in our Armacell Energy Group, and I will be your presenter today. And the aim of today's webinar is to learn why noise and noise control are important in operating a safe, compliant industrial facility. This is going to include a high-level view of acoustic insulation systems that can be utilized for noise control, and why the definition of your noise problem is key to selecting the right solutions. Then I'd like to show how the process of our acoustic technical guidance really is utilized to best solve any potential noise challenges. And then I will present some examples of solutions and services that Armacell has offered and demonstrate how we put the principles of noise control into practice to give the correct solutions in the most efficient manner. So first, let's understand why noise is important. We'll look at the fundamentals of really what noise is, why noise control is important, and then a little bit of a dive into the noise laws and regulations that you might be familiar with in North America. So what is noise? Well, sound and noise are often used together or interchangeably. How many times have you heard or really even used the term quote unquote noise level? Well, sound travels as a wave, specifically as a pressure wave, and as such, a sound wave needs a medium, something to propagate in. This could be a gas, a liquid, or even a solid. For the purposes of this presentation, we're going to be talking about sound propagating in air. Now, noise is generally considered to be unwanted or even annoying sound. It can be good or bad, If you consider something like the noise of an alarm, I mean, this can be viewed as annoying or bad if you live nearby, but perhaps that alarm is essential if you work there. Noise is often considered to be loud, and for most purposes, it is. But equally, the tiny sound of even someone's earphones, say on a public transport or in the office, while it's not loud, it can be very irritating. So, noise can possibly injure an individual directly, or it can even be a factor in long-term health, such as things like stress or even heart disease. So, but generally speaking, unless it's specifically for the good of its purpose, noise requires controlling and reducing, or even possibly eliminating. Now, as good timing of this webinar would have it, DI recently published a blog article called Three Things You Need to Know About Acoustical and Sound Control Insulation. I would encourage the audience to read this article as I think it's very well written and it is informative. Now, if you look at this article, it states specifically, if you work in the construction and manufacturing industries, you know that sometimes noise is simply part of the job. But excessive noise, especially over time, is more than just a nuisance. Repeated exposure to loud sounds can cause accidents on the job and can even result in permanent hearing loss long term. As we all know, and probably most of us have experienced, industrial processes generate a certain amount of noise, and exposure to this noise is very often considered a danger in the workplace. Energy operators are expected to take tougher measures to lower noise levels to protect not just the employees, but also the site contractors who work in these environments. You know, excessive noise also causes disturbance to the neighboring residential communities, and they may even interfere with the behavior of local wildlife. Now, local legislation does exist to ensure that the site does not exceed any predetermined noise levels, and legislation is often determined by local government, environmental, health, and safety laws. And this will vary from one jurisdiction to another. But in areas where no or say little government legislation exists, plant owners can actually implement their own, say, corporate requirements. But penalties can be severe if these limits are violated, and this severity may vary. As we're going to see in the coming slides, sound control insulation reduces the transmission of unwanted noise while also protecting workers. So clearly, quieter is better, right? But what are the specific regulations that we'll see in the U.S. or generally in North America? We know that acoustics or noise is very important, but sometimes it is a forgotten design criteria for systems. So I just quickly want to paint a picture of what regulations these plants are required to follow, okay? As you are likely aware, OSHA governs the health and safety requirements in North America since they are a part of the Department of Labor. And within the specific standard that has to do with occupational noise exposure, says that if an employer has noise exposure levels that exceed what's called an action level of 85 decibels over an 8-hour shift, a series of health monitoring and recording must be undertaken and hearing protection is required. So this process requires work areas and employees to be monitored and recorded. So when I use the phrase limit, that's actually a legal defined limit that cannot be breached or should not be breached. An action level is the point where action on behalf of the plant is actually required. So this does represent a serious undertaking that is both time consuming and expensive. In addition to that, there does exist what's called a permissible exposure limit that should not be exceeded. And where this limit is exceeded, noise controls should be implemented. So what does this mean? What is the cost really of not meeting these action levels or these limits? Well, there is data that's obtained from 2015 by the CDC that shows that specific fines issued by OSHA were around $1.4 million in fines across just the US in all industries. The concern is the potential even additional cost to businesses for not following the requirements. And this cost can be measured in terms of dollars spent on hearing loss claims through, say, workers' compensation insurance claims, or even it can be even be direct litigation, perhaps against companies. The National Institute for Occupational Safety and Health, they actually estimate that 22 million workers are exposed to hazardous noise levels every year. And in addition to damaging the worker's quality of life, obviously this occupational hearing loss carries a high economic burden. So an estimated $242 million is actually spent annually on workers' compensation for hearing loss disability. So what are we trying to say? The key takeaway here is that these plants are all held to complying with health and safety regulations regarding noise exposure. And it is our job to make decision makers aware of how insulation specifically can help play an important role really in this critical area. So noise is an issue that needs to be addressed. How do we do this? Well, noise control. But where do we start? Firstly, we know that sound or noise has a defined frequency behavior, and we know that different materials are going to respond differently to those frequencies. So how do we know which noise control materials to use, and how are they characterized and tested? If you look at each sound source, it has really its own sound, call it a fingerprint of frequency characteristics. And these characteristics add up to an overall sound level. Here, what I'm showing, you see typical sound characteristics in terms of the frequencies that are generated, just for some common industrial sound sources. And when we select noise control, it's necessary to not only to establish what the overall sound level is, but what frequency characteristics are contributing to that overall sound level. And by understanding those frequency characteristics of those sound sources that are going to require the control, it is possible to determine which solution will be required. And we have seen that material properties have different behaviors at different frequencies, things such as stiffness, mass, damping, things like this. So how do we establish the acoustic performance of materials to help determine their suitability to providing noise control solutions? Well, there are a number of American and international standards that allow for the standardization of testing and certifying acoustic materials for their ability to absorb and restrict the passage of sound in different circumstances. And by understanding the nature of the sound or the noise you're trying to reduce, you can understand the frequencies of the sound level that need to be reduced. Therefore, it is necessary to use the correct material characteristics that match the frequencies you are trying to attenuate. So depending on the use of the materials and the function that they will be required to operate under, the test and reporting parameters will be different. So for example, you may have heard of a material needing to meet an STC, which is what's known as a sound transmission class. This parameter is used to describe the ability of a material to restrict the passage of sound through it. So the higher the STC, the better it is at preventing sound from passing through it. Now for pipe work, there is a standard ASTM E122 that sets forward the same test method as an ISO standard 15665, but it does not describe any classification of the results. And this is where the ISO 15665 comes in. This attributes the results against reference curves and actually classifies the material accordingly. So similar to an STC test, the sound source is applied to the inside of a pipe. The pipe passes through a reverberant test room, and just with the bare pipe, the diffused sound in the test room is measured. And then you apply an insulation material or a system to the pipe in that room, and then that same test is repeated. By comparing and subtracting the results of the bare pipe from the insulated pipes, this gives you what's known as an insertion loss, or simply put, it's a reduction in the sound level. So to obtain an ISO classification A, B, C, or a Class D using the addendum in the Shell DEP specification, the insulation material under the test has to meet or exceed the reference curve frequency insertion loss values. So for example, it is possible that maybe many of you have actually seen an insulation specification for a project that say has a quote unquote Class C acoustic insulation material requirement. Well, this ISO 15665 is most likely where this requirement comes from. So in the next couple slides, we will look at two different insulation material types that when used as a system, they will contribute to the compliance of this A, B, C, or D classification of the ISO and Shell DEP standards. First is an acoustic system based on flexible elastomeric foam, FEF, or rubber, as some of you may call it. I don't want to dive today too deeply into the weeds with graphs and technical information and bore you, but really rather than just hit the tops of the waves on the important things that I think are critical to understand. The gray dotted line in these graphs, they represent a reference curve. Now, this curve was established from a series of round-robin testing of mineral oil-based systems, and the average of these tests was actually adopted to be used as a reference curve. And this was done back probably roughly, I want to say around 30 years ago. As with anything, material technology has advanced since then, but these reference curves remain the same. So any new acoustic insulation system, they have to meet or exceed these reference curves. So in this example, the green line curves, they represent the results of an elastomeric foam-based system, meaning the classes A through D. And this ISO 15665, it is applicable to the acoustic insulation of cylindrical steel pipes and to their piping components. It is not, however, applicable to the acoustic insulation of things like vessels, machinery, or even, say, rectangular ducting. Acoustic insulation systems, if you're talking just in the wheelhouse of elastomeric foam, what are some of the good things? Well, these materials are water repellent. They're very flexible. They don't contain dust or fibers, and they do have excellent protection against corrosion under insulation, or CUI, which is typically critical, right, in the design of acoustic systems in really aggressive industrial applications that I'm sure most of us work in. But with that, compared to, say, alternative materials, elastomeric systems do have a more limited temperature range, both hot and cold, and the installation can typically take a little bit longer. And this is due to the additional sealing and adhering that is required as compared to alternative systems such as mineral wool or even aerogel. Now, similar to the last slide, the results here show the insertion loss performance of an aerogel based acoustic system solution, which also is fully compliant and meets the class A through D performance. Now, what's important to note is that apart from the classification, it is the insertion loss performance at each of these systems at individual frequencies. So if going back to the discussion about sound source and frequency characteristics, you can see how if you have a pipe noise source with dominant frequencies, then depending on how much overall or specific frequency reduction is needed, you would then select the relevant system with the necessary insertion loss or sound reduction at those frequencies. So acoustic systems based on aerogel, they do offer a multitude of benefits. These systems can significantly reduce the total thickness, right? It will be a reduced total number of layers across the entire system of the acoustic components, which obviously will save on installation costs, right? And this aerogel does cover the most common temperature spectrum for hot and cold industrial applications. It is flexible, and again, being hydrophobic, this also offers those great CUI mitigation properties. And with that, as compared to alternative or conventional systems, aerogel as a material is generally a higher cost product, and it is dusty, which some specifiers may or may not consider important in their design criteria when they're writing the spec for the system. So these systems are an example of how an alternative or hybrid acoustic system solution based on elastomeric foam or aerogel products can deliver additional customer benefits. These systems are a noise control solution that truly minimizes the risk of that CUI, which, as we all know, is such a critical topic in the world that we all are in. And these acoustic systems are What they're doing is essentially combining thermal and noise reduction into a single solution, being up to potentially 60% thinner than traditional systems and up to 50% lighter in weight. Obviously, these things offer significant savings from an installation and maintenance cost perspective. But the real secret is in the engineered multi-layer system and understanding how these different materials will behave when used together to solve a noise problem, really by meeting the highest level of sound attenuation and insertion loss classification. So earlier we identified that a sound environment has multiple sound sources, right? We also know that the content of the noise problem will really dictate the type of material and solution you need to use to resolve the problem. However, if your facility has a noise problem, where is the exact problem? How do you identify where you need to put the noise control for it to be effective? So let's explore that a little bit further together. I'd like to give a high-level description of the process and methodology that Armacell employs through our acoustic technical service team. Now, to ensure a successful acoustic project, whether it's a CapEx new build or it's an OpEx or maintenance, it is advised that a regular procedure is adopted. Essentially call it a hand-holding exercise, if you will. Armacell's acoustic service team is able to interject at any stage of the process, but the earlier we are involved, the more likely a successful outcome can be achieved. So when it comes to noise control, it is necessary to understand what you are dealing with. Merely saying that a process line is noisy and needs noise control is a good start, but just answers the question, do I have a noise problem? While the answer is yes, what is the actual problem? So to understand what you're dealing with, it becomes necessary to frame that problem. What is driving the noise? Why is it perceived to be a problem? Is it a health and safety issue, or is it an environmental disturbance? In short, what is your ideal target to say that the problem is resolved or solved? Once you know what your target sound level is, you can start to investigate the cause of the problem, right? Ideally, it becomes necessary to make some detailed sound level measurements in or around the area of concern. It is now necessary to really get to the bottom of what is causing the issue. And as I mentioned earlier, multiple sound sources comprise, if you think of an overall sound environment, but only through really detailed measurement techniques is it possible to break down all of the necessary components that do require attention. And once all these components have been categorized, it will be necessary to create, call it a simulation of the problem. And this simulation will comprise of a calibrated acoustic model that will accurately recreate the situation at hand. And this simulation will be able to show clearly which of the system components are causing the problem and need to be addressed. So using this calibrated model, each component can have a noise control solution applied to it, and then the simulation can actually be rerun to determine the degree to which the mitigation is actually successful. So once the model has correctly determined the noise control required to meet a certain level, discussions should be held to establish how suitable is even that solution. Elements such as operability, things like maintenance, inspection, and we can't forget cost, right? All of these things need to be discussed and they have to be explored. So, but by following this process, this will help to ensure that the best possible noise control has been selected and applied to any given situation. Not only does this approach work, but the solutions are often the best possible for the cost itself. So you're not just creating an effective solution, but ideally creating also an efficient solution. So essentially, what is an acoustic technical service program doing in a nutshell? First, we're defining the problem. We're conducting that investigation and analysis of the sound environment, revealing the nature of the problem. We can then identify where the problem occurs and how to further resolve the issue. Then we're going to understand the problem. And this is that detailed study of each of those high noise areas, that are going to lead to identifying the specific causes of the noise problem. And this understanding allows us to develop a range of appropriate, not just one, but a range of appropriate solutions and the benefits that they each have. And then lastly, that's where you recommend a solution to solve the problem. And the solutions we recommend and the benefits they provide, these can easily be demonstrated, which this can include an actual on-site, being at the project confirmation of the success. Now, hopefully, you can see how the determination of the contribution of the components of the sound environment can help to direct the noise control study, if you want to call it that. And once you know what you're dealing with, you can then start to compile and apply the correct solutions and meet your target. So in this next section, we'll just take a look at how Armacell has addressed client noise issues and identified the equipment components that were causing the problem. We were then able to look at noise control options and then actually apply them to our process. And this allowed us to use the material data test results to reduce the sound source levels and show the benefits that could be achieved by using insulation solutions. So let's take a quick look at two specific project examples. So in this first example, we're going to look at an LNG facility. So an LNG operator discovered that they had a noise problem when occupational health determined that an area with a hearing protection zone was not complying with health and safety requirements. Sound pressure levels in the area were found to be up to 115 decibels, and they needed to be reduced. As with step one of our process, a very detailed assessment of the issue determined that the client had actually removed a previous acoustic insulation due to a corrosion or insulation risk. And as per part two of our process, then an acoustic measurement survey was conducted and mapped the sound pressure levels of the site and the sound intensity measurements of the significant components. In this case, it was process pipework and compressors. So we acoustically modeled the site and calibrated the model using our measurements. This is kind of part 3 and 4 of our process. And then key noise sources were identified and appropriate solutions were presented. In other words, a proof of the concept, the benefits, but also can't forget the proof of the costs. And by measuring specific pipework noise, we were able to specify exact insulation requirements and demonstrate impact of those pipes on the site noise level. So as shown here on the slide, we offered 3 different system solutions. And based on the results, the ease of inspection, maintenance of the system, and that protection against CUI, the client opted for a Class C solution. By being on site, we found that the client actually had the same issue on a second compressor train at this facility and could extend our solutions to solve a problem the client was not really aware of at that time. So not only were we able to reduce area noise to acceptable levels, we're able to do so by removing the issue of CUI concern that site had, helping to reduce inspection and maintenance costs. And just as one final example, we were able to actually help resolve a problem completely remotely. Due to COVID restrictions, nobody was allowed to actually be on site. So this is an example of a client that had just commissioned a wet gas compressor, and the pipework for the compressor was experiencing high noise and vibration, and they asked us to help them find a resolution. So again, sometimes it's not always possible to survey the site or to take measurements. Sometimes, though, we can take the measurements from the operator or even one of their, say, acoustic consultants that they work with. In this specific example, operation of this package under certain conditions led to both high noise and vibration. And that may have led to the pipework having integrity breaches, and it was found to be a dominant noise source that gave rise to the exceedance, really, of the area occupational noise limits. And the client initially thought that insulation would fix the vibration problem, but unfortunately, maybe a key learning lesson here is that Acoustic insulation will not reduce vibration, unfortunately, in large diameter pipework. However, when working with the client, we were able to establish realistic targets and advise that the acoustic insulation could in fact reduce the high level noise issue, and that by working in tandem with a specific vibration damping system, it would actually be possible to rectify both the noise and the vibration issues. So the client had originally used an external consultant to look at the issue, which we were able to use the consultant exported data, thousands of data points, and actually build an acoustic model of the current situation and run some simulations to identify which acoustic insulation system would be best suited to reducing the area noise. So using the model, we could apply the sound reduction provided by acoustic insulation systems and the benefit of using each type of system and how it would help reduce the problem that was apparent. So in this scenario, it was decided that the optimal solution was a Class C option. Ultimately, the client will apply a constrained layer damping system for the vibration and this Class C insulation system on top for the noise reduction. And this solution was achieved without the need to attend the site for a survey, which for the current pandemic that we all live in that situation, with the on-site restrictions that we face. So this is actually able to be done remotely. So there are two key documents that provide the details of what we discussed today. First is our brochure on our acoustic technical services, and this 4-page document really highlights the product methodology that I went over today and the services we provide, and explains why having acoustic services are valuable to an owner. Next is the brochure with more detailed information on the specifics of the industrial insulation system for acoustics. This is a 20-page document that it really provides a high-level explanation of the key benefits and then goes into more detail on each layer component. And this includes materials that we don't even discuss today, such as materials that are offered like mass-loaded vinyl, which are a component of the acoustic system. But also this brochure, or guide rather, it provides technical graphs showing the exact level of performance per that ISO 15665 requirements. These documents can be found on our website, and I always encourage folks to share these documents with your clients when necessary. So, in summary, we've covered the basics of what noise is and how it's defined and represented. The way sound interacts with different materials depends on those sound level frequencies and the properties of the materials. Armacell Acoustic Services really aims to support clients by helping identify the cause of those noise problems. And by doing so, the ultimate aim is to provide advice and solutions. And maybe most importantly, you still have to demonstrate that those solutions will work and will continue to work. We achieve this, right, by using measurements, modeling, and kind of using what I would call almost a consultant-based approach to this. Not a sales type approach and all our products are great, but really acting as almost a consultant for the owner. Now, I've emphasized that to correctly assign noise control measures to solve a noise problem, we need to understand what sound sources are causing the problem and their characteristics. And only by understanding these aspects can the correct solutions be applied to the correct location. And by following this procedure, it should be possible to solve their noise problems successfully and efficiently. So ultimately, let's work together to understand if the industrial facilities in your territory do have acoustic issues or there's opportunities. And if the answer to the question, do you have a noise problem, is yes, Armacell, we can help. And that brings us to the end of the presentation. I'd really like to thank you all so much for joining today and being part of this webinar. We'd also like to thank DI for being a great host and bringing us all together. I really hope that the information was valuable and that it will be helpful in your future installation decision making. Here you can see my personal contact information. While I am not our resident acoustics specialist or expert, I would encourage you to reach out with any inquiries that you might have, and certainly can work with our team of acoustics engineers to answer any questions. And with that, yeah, just thanks again, everybody.
Thanks, Jack. We really appreciate it. Some great information there. Just a reminder, if you have questions, use the questions tab on your GoToWebinar control panel and you can submit them there. While we're waiting on some questions to come in, I do just want to remind everybody about to go take a look. If you haven't seen Distribution International's new website, go check that out. We have an exceptional customer platform that we call Customer Connect. You can search our full catalog online. You can even make purchases online, request quotes, view past invoices, check order status, all that good stuff. So check that out. It's a great resource. Don't have any questions yet. I know we have Sandy Shaddles also on as a panelist. Sandy, while we're waiting for questions, is there anything you would like to add? I put Sandy on the spot.
I'm sorry, I was talking on mute. I apologize. No, I just want to thank Jack for the presentation today. Again, thank you to DI. We really appreciate the opportunity. I know a lot of people, when they think of Armacell, they think of flexible, elastomeric, and commercial applications, but there's a whole world of industrial application solutions that we offer, and we just wanted to expose you guys to a little bit of that education. And we are here to answer any future questions or help with any future projects that you may be considering or working on right now. You know, as Jack mentioned, you can reach out directly to Jack and we will get you in touch with the right person.
Yeah, just to add on to that, one comment on our website, there is also an area where you could submit inquiries specific to acoustic related things, and you can provide information that will go directly to our team of acoustics experts. So whether you reach out to me, submit an inquiry online, we'll get you taken care of.
Thanks, Jack. We do not have any questions, but we had several people submit comments. Great job. Thank you for the information and all that good stuff. So it looks like you've answered everybody's questions already, Jack. Great job. We appreciate it. Will let everybody know that we did record this webinar. We will post it to our YouTube channel and website. So if you missed it, or if there's anything you want to go back, well, you obviously didn't miss it because you're here. If you want to share it, or if you want to go back and see if there's anything that you didn't catch, you will be able to do that. Go to our website and click on resources. That is it. Thank you, everybody, and enjoy the rest of your week.
Thank you.